Members of our team, the general manager is Freda, the production manager is Xian, the QC and QR manager is Dongmianze, the logistic manager is Gigi, the plant manager is Roy Han, the sales and the customer service manager is Lu Xiqin. Product is whole fish with the guts removed, cut it into chunks and fermented by salting. The fish is high-quality freshwater fish that is free from harmful substances and sterilized through high-temperature cooking. It can be consumed directly or as a seasoning cooking. The target customers are dairy householders, restaurant, food service industry, and food processing companies. For the distribution control and the storage, remember to refresh it at 0 to 4 degrees and the shelf life is 3 months. You can buy it from Lazada, retail store, and shop.
The production of ready-to-eat Pekasam begins with receiving freshwater fish from approved supplier where the fish are kept under chill conditions to maintain freshness. The fish are inspected to ensure only good quality and raw material are used. Next, the fish is cleaned and cut into uniform size to ensure the consistent processing excess. Excess water is removed through the draining process before the fish are salted to enhance flavor preservation. Roasted rice is also prepared by roasting and grinding, which play an important role in fermentation. The salted fish is then mixed with roasted rice and seasoning. This mixture is left ferment under control. Temperature conditions for several days, allowing the development of its characteristic taste and texture. After fermentation, the product is cooked and ensure it fully cooked to save for consumption. The cooked product is cooled quickly to maintain quality and prevent spoilage. Once cooled, the product is packing using vacuum packaging to protect it from contamination and extend shelf life. The final product then goes through metal detection to ensure there are no physical hazard. Finally, the product stored under chill condition to distributor under control conditions to maintain quality until it reaches the consumer.
So now I will explain the hazard analysis of Pekasam processing. The first step is receiving raw fish, which is a CCP. The significant hazard is microbial contamination and histamine formation caused by temperature abuse after catch. The control strategies target the temperature control of fish after catch, which include rejecting fish with internal temperature above 4 degrees Celsius, verifying catch to delivery time under 6 hours, and using approved suppliers with cold chain verification. Next, inspection is not a CCP, although spoiled fish can cross-contaminate other fish. This is controlled by visual checks for sunken eyes, red gills, and foul odor. Thus, spoiled fish can be simply removed together with physical contaminants. Cleaning, evisceration, cutting, and draining are not CCPs. The main hazard is pathogen cross-contamination from fish guts or equipment. However, these steps are managed by good manufacturing practices, GMP, and operational prerequisite programs, while physical hazards like metal fragments are controlled by metal detection later. Salting is a CCP because insufficient salt concentration allows pathogens like Clostridium botulinum and Listeria to survive or grow, and no subsequent step except frying can control these pathogens if salting fails. The critical limit is minimum 10% salt concentration with 24 to 36 hours salting time, ensuring effective water activity reduction. Next, roasted rice preparation and mixing are not CCPs because hazards can be controlled by prerequisite programs such as proper roasting temperature and time, proper sanitation, supplier approval, visual inspection, and sieving. That's all from me. Thank you.
Fermentation is considered as CCP. The main hazard is the growth of pathogens and spoilage microorganisms due to improper fermentation conditions. Thus, salt concentration, fermentation temperature, and time must be strictly maintained and monitored throughout the process. Next, cooking is also CCP. The main hazard is the survival of pathogens. Appropriate cooking temperature and time must be applied to kill or reduce pathogens and ensure that the product reach an internal temperature of at least 75 degrees Celsius. For both process, chemical hazards can be controlled through prerequisite programs like proper cleaning procedures, while physical hazards can be prevented through regular maintenance and inspection of equipment. Cooling is another CCP because slow cooling after cooking may allow the cooked fish to remain within the danger zone, which is 4 degrees Celsius to 60 degrees Celsius, which promotes microbial growth. Thus, cooling temperature and time must be controlled to prevent post-cooking microbial growth. However, packaging is not CCP since the hazards can be controlled through prerequisite programs and good manufacturing practices (GMP), including proper hygiene, sanitation, use of approved food-grade packaging material, and regular inspection of packaging integrity and vacuum sealing equipment. Metal detection is a CCP because the metal fragments may be introduced during processing and cause injury to consumers. Control measures include using automatic metal detector with rejection system, routine performance testing, and ensure all packaged products pass through the metal detectors. Besides, storage is also a CCP. The significant hazard is the microbial growth due to improper temperature control. Thus, the storage temperature must be controlled within temperature not more than 4 degrees Celsius, and temperature monitoring should be conducted daily. Last but not least, distribution is not a CCP since temperature abuse during transportation, chemical contamination from transport environment, and physical damage to packaging can be controlled through prerequisite programs and GMP. That's all from me, thank you.
So today, let us start with CCP1, which is receiving raw fish. At this step, the hazards are pathogenic bacteria, histamine formation, and heavy metals. To control this, our critical limit is that the fish receiving temperature must be 4 degrees Celsius or lower. The fish must also look fresh and have no bad smell. Our QC executive will check the temperature of every batch using a calibrated thermometer. If the temperature is higher than 4 degrees, or if the fish looks spoiled, we will reject the batch immediately and return it to the supplier. CCP2, the salting process. The hazard here is the survival and the growth of dangerous bacteria such as Clostridium botulinum and Salmonella. Our critical limit is a salt concentration of 10 to 15% of NaCl, and it must be distributed evenly across the fish. The production supervisor will monitor this by weighing the salt and checking the mixture visually for every batches. If the salt is not enough or not even, the corrective action is to apply the salt immediately and hold the batch for safety evaluation. Now we will look at CCP3, the fermentation process. If fermentation is not done correctly, pathogen and spoilage microorganisms will grow. Then we have 3 important critical limits. First, the fermentation temperature must be between 25 to 30 degrees Celsius. Second, the final pH must be 4.5 or lower. Third, the fermentation time must be 5 to 7 days. Our QC executive will check the temperature and pH daily using a thermometer and pH meter. If the temperature is wrong, we will adjust the room temperature. If the pH target is not reached, we will extend the fermentation time. If it is still unsafe, the product will be discarded.
Okay, so for critical control point 4, which is cooking, the critical limit must be internal temperature must reach at least 75 degrees Celsius for 50 seconds to eliminate the pathogenic microorganism in the fermented fish product. For the monitoring and corrective action, production workers and QC executive use calibrated probe thermometers and timers for every batch. If the required temperature is not achieved, cooking continues until the critical limit is met. And for verification and records, the thermometer calibration and microbiological testing of cooked product and the records include cooking temperature logs, calibration records, maintenance records, and tested reports. Okay, so for critical control point 5, which is cooling, cools the product from 60 degrees to 4 degrees Celsius within 4 hours to control the post-cooking microbial growth. Production workers and QC executive monitor every batch with calibrated thermometers and timer. If the limit is exceeded, the cooling system is adjusted and the product is evaluated. Records include temperature logs, corrective action reports, and maintenance records. And for critical control point 6, which is metal detection, prevents physical contamination from metal fragments. No detectable metal fragments permitted in the final product. Automated metal detector with rejection mechanism runs continuously. Contaminated batch are rescreened and the source is investigated. Records include detector logs, rejected product records, calibration records, and maintenance report. Okay, lastly, for the critical control point 7, which is storage. It controls the growth of Listeria monocytogenes and Clostridium botulinum in vacuum-packed product. The critical limits, which is store temperature within 0 to 4 degrees Celsius. Vacuum packaging must remain intact and no leakage or damage. Monitoring and corrective action, which is automated temperature monitoring, calibrated thermometers, and daily visual packaging inspection. If the temperature limit exceeds the limits or the damage is detected, refrigeration is adjusted immediately and the products are segregated for evaluation. And for the verification and records, regular calibration of monitoring device and routine inspection of storage records. Records include temperature logs, packaging inspection records, corrective action reports, and maintenance records.